Struggling with power outages or looking for truly sustainable energy? What if the solution was literally growing on your wall? We're tackling urban waste and energy needs head-on by building a bottle garden battery, a vertical green wall that leverages bioelectricity from plants to power small devices. It's an ingenious way to upcycle, green your space, and generate clean energy all at once. Our cities face a perfect storm of energy challenges that demand creative, sustainable solutions. Urban centers worldwide consume approximately 75% of global energy while housing just over half the world's population, and this demand continues climbing as more people migrate to metropolitan areas. At the same time, we're drowning in plastic waste, with millions of bottles ending up in landfills and oceans every single day. The conventional approach of relying solely on centralized power grids leaves us vulnerable to outages, brownouts, and the environmental toll of fossil fuel dependence. What makes this situation particularly frustrating is that we have green spaces right in our homes and balconies that could be doing so much more than just looking pretty. Plants are already working hard, photosynthesizing, growing, and interacting with complex ecosystems of soil microorganisms. The question that forward-thinking gardeners and scientists have been asking is this: can we harness the natural electrical processes happening in our gardens to generate usable power? The answer is a resounding yes, and it's more accessible than you might think. The concept of plants as power generators might sound like science fiction, but it's rooted in solid, proven science. Every time a plant photosynthesizes, it produces organic compounds that feed beneficial microbes in the soil. These microbes, in their process of breaking down organic matter, release electrons as a natural byproduct. With the right setup, we can capture those electrons and direct them into an electrical current. This isn't about genetic modification or complicated laboratory equipment. It's about understanding and tapping into the natural electrochemical processes that have been occurring in soil for millions of years. Building your bottle garden battery starts with rescuing plastic bottles from the waste stream and giving them new purpose as vertical garden modules. You'll want to collect clear plastic bottles of similar sizes. Typically 1 to 2 liter bottles work beautifully for this application. The transparency allows you to monitor root growth and soil moisture, while the sturdy construction holds up well to repeated watering cycles. Before you begin cutting, clean each bottle thoroughly and remove all labels. The beauty of this system is its modularity. You can start with just a few bottles and expand as you gain confidence and see results. The transformation process involves cutting each bottle strategically to create planting chambers while maintaining structural integrity. Make a large rectangular opening on one side of the bottle, leaving about 2 inches at the top and bottom intact. This opening becomes your planting window. At the bottom of each bottle, drill several small drainage holes to prevent waterlogging, which would disrupt the microbial activity we're counting on for electricity generation. You'll also need to create connection points, either by drilling holes for zip ties or using a heat source to carefully melt attachment points where bottles can be secured to a vertical frame or directly to a wall structure. Now comes the fascinating part: integrating the electrodes that will capture the bioelectricity. For each bottle unit, you'll need 2 types of electrodes: an anode buried in the soil near the root zone, and a cathode positioned differently. The anode can be made from graphite, felt, carbon fiber, cloth, or even activated carbon granules mixed into the soil. These carbon-based materials are non-toxic to plants and excellent at collecting electrons from soil bacteria. The cathode, which completes the electrical circuit, can be constructed from copper wire or mesh positioned in a separate chamber or in the drainage area with exposure to oxygen. The key is creating an oxygen gradient, with the anode in the oxygen-poor root zone, and the cathode where air can reach. Plant selection dramatically impacts your system's electricity generation capacity. You want vigorous growers with extensive root systems that exude plenty of organic compounds. Rice plants, certain grasses and sedges have been studied extensively in microbial fuel cell research because they naturally release significant amounts of organic matter through their roots. For practical bottle gardens, consider plants like lucky bamboo, pothos, spider plants, and certain varieties of ornamental grasses. These species establish quickly, tolerate the confined space of bottle gardens, produce abundant root exudates to feed electricity-generating bacteria, and many of them thrive in lower light conditions, perfect for indoor walls. The growing medium itself requires thoughtful composition. Standard potting soil works, but you'll enhance electricity generation by incorporating materials that support microbial communities and conductivity. Mix in some coconut coir for water retention, a portion of compost rich in diverse microorganisms, and a small amount of biochar or activated charcoal to increase the soil's electrical conductivity. Some innovative gardeners even add a thin layer of conductive materials like graphite powder or carbon black to the soil mix. The goal is creating an environment where electrochemically active bacteria can thrive while supporting healthy plant growth. So, the science behind your bottle garden battery operates on principles that are both ancient and, honestly, pretty cutting edge. At its heart is the microbial fuel cell, which is a biological system that converts chemical energy directly into electrical energy through the metabolic activities of microorganisms. When your plants photosynthesize, they produce sugars and other organic compounds. Up to 40% of these compounds are released through the roots into the surrounding soil, and this process is called rhizodeposition. Now this isn't waste, it's actually how plants communicate with and feed beneficial soil organisms. Enter the electrochemically active bacteria, who are, the unsung heroes of your biobattery. These remarkable microorganisms, including species like Geobacter and Shewanella, have this unique ability to transfer electrons to external conductors like our buried electrodes. As they consume the organic compounds from plant roots, their metabolic processes strip electrons from these molecules, and instead of passing these electrons to oxygen like most bacteria do, electrochemically active bacteria can actually deposit them directly onto conductive surfaces. So when you've embedded graphite or carbon electrodes in the soil, these bacteria essentially wire themselves to your electrode, forming biofilms that act as living electrical cables. The electrical current flows because you've created a battery-like setup with two different environments. At the anode buried in the soil, bacteria are oxidizing organic matter and releasing electrons and protons. These electrons travel through your external circuit, which is just the wires connecting your bottles where they can power small devices before reaching the cathode. Meanwhile, the protons migrate through the soil moisture to the cathode, where they combine with oxygen and the returning electrons to form water. This completes the circuit and keeps the process running as long as your plants are alive and photosynthesizing. The voltage generated by a single bottle unit is pretty modest, typically between 0.4 and 0.8 volts with very low current measured in milliamps. This won't charge your phone directly, but here's where the magic of series and parallel connections comes in. When you connect multiple bottle units in series, meaning positive to negative in a chain, the voltages add up, while the current stays the same. Connect them in parallel, and you maintain the voltage while increasing the available current. With a well-designed wall of, say, 20 to 30 bottle units properly connected, you can generate enough power to keep LED lights running, charge small battery banks, or power ultra-low power sensors and devices continuously. The true potential of bottle garden batteries, honestly, really shines when you start to think beyond just a single unit and imagine entire walls quietly generating continuous power. Picture this, a vertical installation of 50 bottle gardens, set up in a beautiful geometric pattern and connected with a clever electrical configuration. It becomes not only a stunning living art piece, but also a genuinely functional power source. The best part is the modular nature. So, you can start small, maybe just 10 bottles on a balcony wall, and then expand over time as your understanding and ambition grow. Each new bottle you add increases your system's total output, and since the components are living organisms, the whole setup actually gets better with time, as microbial communities mature and the plants develop strong root systems. Integrating with existing smart home technology opens up some really exciting possibilities. The steady low-level power output from bottle garden batteries is perfect for wireless sensor networks that monitor things like environmental conditions throughout your home. Devices such as temperature sensors, humidity monitors, and air quality detectors use very little power and can basically run indefinitely on the current from your green wall. Some innovators are even powering mesh network nodes, creating whole-home connectivity without having to rely on traditional power sources. It's a beautiful synergy. The plants improve your indoor air quality, while at the same time, they power the sensors that actually measure those improvements. Now, For those of you who are interested in pushing the boundaries a bit, you might want to think about supplementing your bottle garden battery with small supercapacitors or rechargeable batteries. These can store the electricity generated during peak production times. You see, on plants tend to generate more electrons during active growth periods and especially during daylight, when photosynthesis is really humming along. By storing this extra energy, you can smooth out the power supply and support devices that need a higher burst of power now and then. For example, a small lithium-ion battery bank, charged continuously by your wall garden, could power all sorts of increasingly sophisticated applications. From decorative LED accent lighting that runs all evening, to keeping emergency communication devices topped up and ready. The future developments in this space are honestly pretty thrilling to think about. Researchers are exploring genetically optimized plants that release more root compounds, working on electrode materials that are way more efficient at collecting electrons, and developing smarter systems for harvesting and managing this bio-generated electricity. Urban planners and architects are even starting to include living, power-generating walls in building designs, imagining structures where the exterior green walls don't just insulate and beautify but actually contribute to the building's energy needs. So, your bottle garden battery isn't just a fun and practical project, it's also your way of participating in a much larger movement toward distributed biological power generation. Alright, so starting your own bottle garden battery journey really begins with a simple first step. Collect 10 to 15 plastic bottles and pick out a wall space that gets indirect natural light, or hey, just install some grow lights if you need to. Then, spend a weekend afternoon transforming those bottles into planting modules, getting your electrode materials ready, and mixing up your growth medium. And honestly, don't let perfection be the enemy of progress. Your first installation is going to teach you lessons that no article can really explain. I suggest starting with hardy, fast-growing plants like pothos or spider plants. They're forgiving for beginners and help establish the root systems you'll need for electricity generation. As you build and connect your bottles, make sure you document everything. Take photos of your electrode placement, jot down which soil mixtures you used in each unit, and get in the habit of measuring the voltage output every week. Trust me, this data becomes invaluable as you optimize and expand your setup. And don't forget to join online communities of bio-battery enthusiasts who are running similar experiments. Go ahead and share your voltage readings, your plant choices, and any creative solutions you come up with for challenges like water drainage or maximizing wall space. This kind of collective knowledge sharing really speeds up everyone's progress and helps us all figure out what techniques and configurations generate the most reliable power. The beauty of this project goes way beyond just the electricity you generate. You're actually creating a living system that cleans your air, adds humidity to dry indoor spaces, brings a touch of nature into urban environments, upcycles waste materials, and generates renewable energy. Every plastic bottle you keep out of a landfill, every little device you power without using grid electricity, and every conversation you spark when someone asks about your incredible wall. These are all meaningful acts of environmental action. This isn't just about gardening or electronics, it's a hands-on demonstration that sustainable solutions can be creative, beautiful, and honestly accessible to anyone who's willing to give it a try. So here's my challenge to you. Go ahead and build your first bottle garden battery this month. Start small, experiment boldly, and share your results with our community. And if you want to stay in the loop, subscribe to EcoCrop Chronicles so you don't miss our upcoming videos on advanced electrode setups and plant species comparisons for maximum power output. Drop a comment below with your biggest question or your first success, and let's build a movement of gardeners generating green power, one upcycled bottle at a time. Together, we're not just growing plants, we're cultivating a more sustainable future that's literally rooted in the power of nature.